Hello everyone, welcome back to today's maths class, chapter number 25, probability, the continued part of exercise 25C. Question number 5. Kindly refer your textbook for the questions. A and B are two friends. Ignoring the leap year, find the probability that both friends will have different birthdays the same birthday. So till today we have solved many problems related to the tossing of a coin, throwing of a dice and drawing some balls from a bag, and the very important question with the playing cards. Now onwards we are going to have the different categories of problems where we can apply probability. Among that, this is one of the question. Try to understand this question, children. Very simple solution, but you need to understand the question very much carefully. It is said that there are two friends, A and B. Just imagine it might be you and your friend. Ignoring the leap year, that means it is not a leap year. Find the probability that both friends will have different birthdays. Now we need to find the probability so that you and your friend will have the birthdays on different dates. It's not on the same day. So how to solve this? See, out of A and B, one may have his birthday on any one of the 365 days of the year. That means to say, in an year there are total number of days in a year is 365, hence total possible outcomes is equal to 365, and the formula remains the same. They told us to calculate, find the probability that both friends will have the birthdays on different days. Imagine children, see if one is having a birthday on any one particular day, then the other one cannot have the birthday on the same day. Now we have 365 days in a year. Among 365 days, any one day will be a birthday of any one person. It might be A or it might be B. Any one person's birthday will be on any one day. So that one day is excluded. So the total number of days is equal to 364. Why we need to exclude one? Why? Because it is said that they both will celebrate birthdays on different days. For example, if A has to celebrate birthday on any particular day, then his birthday should not be same as birthday of B. So then that birthday of B is he cannot include in his birthday list. So that one day is the birthday of B which has to be removed. So then A's birthday will be on any one of the day among the remaining 364 days. Let me clear it out, children. See, now as it is not mentioned it is A or B, let us consider and try to understand with the person names A and B. Now you have A, you have B. Total number of days is equal to 365. If among 365 days, if one day is taken for A as his birthday, then total number of days remaining is 364. Now B has to choose, or B's birthday will be on any one of the day of the remaining 364 days, and he cannot take it from 365. Why? Because it is said that they both are going to have birthday on different days. If B selects a birthday from 365, if it is same, then the condition will not be fulfilled. So we have to think it very much practically. So out of 365, one day is removed as the birthday of any one person, then the total number of remaining days is equal to 364. Hence the other person can have a birthday on any one of the 364 days and not of any one day related to 365. And the second sub question, it is the same birthday. So they both can have the birthday on same day. That means there is no choice. Both can have birthday on same day means it is only one day. and the probability is 1 by 365. Question number 6. A man tosses two different coins, one of rupees 2 and one of another rupees 5. Simultaneously, what is the probability that he gets at least one head, at most one head? The problem is 100% similar, children, but only the major difference is they said that two coins are tossed. Among that, one coin is of rupees 2 and one more coin is of rupees 5. So that information doesn't matter for us. For us, what we need that there are two coins. That is only an extra information just to make us to know how smart we are in reading the question. So let us neglect that part, whether the coin is of 2 rupee or 5 rupee or 1 rupee or 50 paise, it doesn't matter for us. For the probability, we need only the head and tail part of a coin. So as there are two coins are tossed, already we have discussed in the previous classes that the total number of all possible outcomes is equal to 4. And the first sub question says at least one head. I already made this point very much clear, children. At least one head means one or more than one. I'll clear it once again. At least one means one and more than one. There is no maximum limit, but minimum is 1, maximum is not limited. In the same way, the second sub question is at most one head. Children, at most one head means maximum is 1 and the minimum might be 0. At most one head, that means maximum you can have one head, that means it can be no head or 0 head also. So these two are very much important topics, children, at least and at most. Try to understand here. At least one head means condition to have at one head, and it can also have more than one. At most one head means maximum 1, and maximum 1 means it can include no head or 0 head, and the number of favorable events are listed out here. In the first sub question, it is head comma tail where we have one head, tail comma head where we have one head, and head comma head there are two heads. Hence the required probability is equal to 3 by 4. And the second question, at most one head, head comma tail, there is one head, tail comma hedge, there is one head, tail comma tail, there is 0. At most means maximum 1, it may have 0 or minimum is 0. Hence the required probability is 3 by 4. Question number 9. In a musical chairs game, a person has become advised to stop playing music at any time within 40 seconds after its start. What is the probability that the music will stop within the first 15 seconds? So nice, the question is, a game of musical chair has been played and the total duration is set as 40 seconds. Hence the total possible outcomes is equal to 40. Now we need to find the probability that the music will stop within the first 15 seconds. So within the first 15 seconds means it may stop at 1, it may stop at 2 seconds, it may stop at 3 seconds, it may stop at 4 seconds. In the similar way, the maximum time given is 15 seconds. So within 15 seconds, how many times it can stop? It can stop for 15 times. Hence the required probability is 15 by 40. Question number 10. In a bundle of 50 shirts, 44 are good and 4 have minor defects and 2 have major defects. What is the probability that it is acceptable to a trader who accepts only a good shirt? It is acceptable to a trader who rejects only a shirt with major defects. We have solved few problems, children, that is a bag contains some red balls, blue balls, yellow balls. This is also similar type of problem. There is in a bundle there are totally 50 shirts. Among this 50, it is categorized as good shirts 44, minor defected shirts 4, major defected shirts 2. Hence, the total number of all possible outcomes is equal to 50. Minor means lesser damage, major defect means more damaged or more defected. Now, the first sub question says that it is acceptable to a trader who accepts only a good shirt. How many good shirts are there? 44. So, as there are 44 good shirts, probability will be equal to 44 by 50, which is equal to 22 by 25. And the second sub question says that it is acceptable to a trader who rejects only a shirt with major defects. See there, in the first sub question they told what he is going to choose. He said he is going to choose good shirts. So we took good shirts as 44. In the second sub question they are saying that he is going to reject the major defect shirt. That means what? Out of 50 there are only 2 shirts with major defects. If 2 shirts are removed, then total number of shirts remaining is 48. He can accept a shirt out of 48. Why? Because 48 in 48 we have only good shirts and shirts with minor damage, and the major damage or major defected shirts are removed. Required probability will be equal to 48 by 50, which is equal to 24 by 24. 24 by 25. Is it 24 by 25? Yes. Thank you, children. Have a nice day.